key thing about fuel cell vehicles is that you can have a vehicle that to use is exactly the same as a conventional vehicle today. It can do the same range, have the same performance, and be refueled in the same period of time. And the targets are to get the cost down and the reliability the same as the current vehicle. This year, the projections for a production system would be around $95 per kilowatt, and an automotive engine would cost more like $30 per kilowatt. And that's the target for 2015. So a few more years development and starting to production, and the cost will be very similar. Fuel cells and batteries actually are natural partners. Let's just take batteries on their own to start with. Battery vehicles are great in all ways, apart from the fact that they can't do a reasonable range, and the cost of batteries is very high. And the cost of batteries isn't likely to come down to the extent that you could have a car that you could use on a reasonable journey. So that's not likely to happen. So hybridizing it, first of all with the internal combustion engine, is the way things are going at the moment, so that the engine can provide the extra energy required when you run out of battery energy. And then the next stage is to incorporate a fuel cell instead of the internal combustion engine. So it's a fuel cell hybrid. And an extra benefit is if that's a plug-in as well, in that you can get the better efficiency by recharging the battery from a power supply. But when you run out of range, you can use the fuel cell and the hydrogen to give you the rest of the range. Today, most of the hydrogen does come from natural gas. And even though it does, it still represents a CO2 saving today. And the steps forward would be through carbon capture, so that you're still using a fossil fuel, but you're producing hydrogen then from the fossil fuel directly and using it in a vehicle. Then the next stages would be to incorporate it into the thermal side of a nuclear reactor, so you're getting hydrogen from a thermochemical reaction, or from high temperature electrolysis, or from biomass processes. So there are many, many routes for producing hydrogen. You have to get the vehicle to a reasonable level of engineering, and the first vehicles are appearing now in California. Honda have produced their fuel cell Clarity, which is a fully engineered vehicle and is available to the public on a lease basis. So this is the first step, but only 200 vehicles in the next 2 years. Gradually, there'll be more market penetration of that and fleet demonstrations. The infrastructure has to be developed around those vehicle fleet demonstrations. Our company hopes to implement 50 to 100 vehicles, fuel cell London taxis for the time of the Olympics, and gradually building up the fleet, getting confidence in the technology, getting confidence in the reliability, and reducing the cost of the components. So that's the stepwise development.